Hey everyone, I'm Andrew Bloomgarden. Thank you for coming. I'm going to be talking today about what I've spent the past year working on, the nth region project at New Relic. So what we've done, me and a small team of people and everyone else at the company, is redesign the infrastructure New Relic runs on to support scalably building and operating many regions. So just to give you a sense of where we're going here, in this talk I'm presenting an open retrospective, talking both about the technical aspects of the project as well as, probably more importantly, the organizational aspects and what we learned. Think of this as a case study in the way that one medium-sized company deals with the challenges of operating at scale. So most of you have probably heard of New Relic, and some of you are probably customers of ours, but let me introduce you to what we do from the perspective of an engineer at the company. New Relic is an observability company that builds software that our customers use to analyze how their software actually works in the wild. That means that our customers send us a ton of data that we then process and store and then present back to them in the form of alerts, curated UIs, and ad hoc queries, all for a variety of different products. Last year, as part of our partnership with IBM, we agreed to build out a new region in Europe in IBM's data centers in Frankfurt in order to be able to let European customers keep their data in the EU. And I'll stop here and note that this isn't the same as some other kinds of multi-region projects where the goal is just availability, redundancy, et cetera, et cetera. We need actual data isolation here. European customers do not want their data to leave the EU. And this was a pretty scary proposition to us in engineering, so let me explain why. When I started at New Relic 8 years ago, we had one app. It was the UI, and it was the data collection tier, all in one. It was a really nice Rails monolith. And it was pretty great to work with. But it had some problems. Most notably, it was slow. So shortly after I started, one of our engineers split out the collection tier into the aptly named collector. And this was written in Java, and it was a couple of orders of magnitude faster and more efficient than our initial Rails implementation of the collection side of things. And if we had stopped here and the business had said, cool, we want to build out a European region, we would have been totally fine. Changing a couple code bases to work in a different place isn't really a big deal. You know, it might have been the wrong business decision at the time because we would have had to take time to do that versus something else, but technically, not really an issue. But we didn't do that. Instead, in 8 years, we've introduced new products and features, and we've scaled enormously. And to handle that growth, we've had to continuously re-architect our software. So currently, and these stats are a month or two old, so they're probably out of date. We're handling around 30 gigabits per second of traffic inbound, processing something like 15 million Kafka messages a second, which translates to around a terabit of traffic just for Kafka. 600 million events per minute are written to disk, and there are about 50 engineering teams with hundreds of engineers, and all of our dev teams are on call for their services. And this is what our architecture looks like today. So, like most service-oriented architectures, this reflects both actual technical requirements, like one thing going down shouldn't affect another thing. This is a good thing to have. And it also reflects organizational requirements, like that team over there is in a different floor than the team over here. Like, these things actually have impacts. And our architecture is at the point where no single easily understandable diagram can represent the architecture in all its complexity. My colleagues Elisa and Matthew talked yesterday about our SLIs and SLOs, and they did a great job of simplifying our architecture. But this is some approximation of reality, and there's no way that you could understand this. And there's no way that our original 1 or 2 app architecture would have scaled to this far, so we made the right choice in building this out. But every step along the way, we were targeting one region. We never really considered the possibility that a European region would actually arrive. Yeah, we talked about it, but it was mostly in the sort of dream talk. Oh, wouldn't it be nice if we ran a European region? Wouldn't it be nice if we had another US region? Et cetera. But we didn't build for it, and it was a potential future that never seemed to actually arrive until it did. And the business said, we actually have to build an EU region. We've signed a deal saying that we're going to do that. And we knew that this was going to be a really painful exercise. And then we confirmed that there was a pretty high chance that no matter what, so let me rephrase that. We had to build an EU region, but there was also a pretty high chance that we would build another, and then another, and then another. I can't tell you where those would be. We don't know yet. But there's a high probability that's going to happen. So we changed the scope of the project and said, this is going to be painful, but the next one shouldn't be. We're going to make this the nth region project. Not 0, not 1, not 2, n. So the next time, hopefully, one small team of people can be in charge of spinning up a new region. And this is an aspirational goal. And we called this project Project Backpack, as we, mostly Americans, were finally getting to go on a trip to Europe. Now, let me talk to you about technical migrations, infrastructure migrations, and disaster recovery. So every year at New Relic, we do a disaster recovery exercise where we prove to ourselves, and more importantly our customers, that in the event of a disaster, we can successfully rebuild the entire New Relic stack in a new environment from scratch. So we actually did have experience building out new regions, and we knew it was incredibly painful. Importantly, we did prove out that in the event of a real emergency, we could drop everything and recover. And that's the most important thing for our customers. They care that we can keep doing business with them. But it took a lot of effort across the entire engineering organization. So when we started the EU region project, we knew we need to look into what actually took so long. Why was it fundamentally painful? So in my 8 years at New Relic, we've had to solve a lot of different problems. We've had to figure out how to deploy many services, going from 1 to 2 to hundreds. We've had to figure out how to support a polyglot environment, Ruby, Java, Elixir, off-the-shelf packages that we run in containers. Have to have some kind of service discovery system, have to have better secret management than what was state-of-the-art in 2010, and we have to have some kind of container orchestration. And now we need to tackle having multiple regions. Earlier this year, I read an article by Will Larson, who worked at Dig, Uber, and now works at Stripe, talking about technical migrations. And he said that migrations are the only mechanism to effectively manage technical debt as your company and code grows. If you don't get effective at software and system migrations, you'll end up languishing in technical debt. And the truth is, we just weren't very good at large-scale infrastructure migrations. So yes, we tackled all of those problems that I talked about, but we tackled it mostly for new things. The primary reason they seemed successful at all was just our fast growth. When you're writing tons of services and spinning up new products, the vast majority of your stuff is going to look new, and it's going to use the new patterns, but the old stuff just didn't really come along for the ride. It stayed behind in whatever pattern was used at the time it was built, and maybe there would be an incident and that would motivate something to change. Okay, now everything's on fire, we have to go containerize that system so we can scale it more easily. That kind of thing did happen, but generally speaking, as long as there weren't problems, systems didn't come along for the ride. And a variety of vintages might be really nice in a wine cellar, but it's not really what you want when you're maintaining large-scale software systems. So let me talk to you about the specific vintages of New Relic so you get a sense of what our problems were. Dating back to 2010, we had applications deployed via Capistrano to hard-coded lists of hosts that were deployed to hosts that were managed with years and years of crufty Puppet code that we just didn't manage well. This was mostly self-inflicted pain. Dating to 2013, this is around the time when we started spinning up a lot of products, a lot of services. We said, okay, there's no way this is going to keep scaling. There's this Docker thing, it's super hot. Turns out it was really early and really spicy, but it saved us. It meant that we could spin up tons of services. Developers could be responsible for the environments those services ran in. But around that time, there wasn't a great orchestration story, so we wrote a Capistrano-style tool called Centurion that let us deploy containers kind of similar to how we were used to deploying them. Around 2013, that same time, we wrote an in-house service discovery system, Cerveza. 2016, we started using Vault. 2017, we said, okay, this Centurion thing, this is not scaling well. Our Jenkins build pipelines are really crufty and hard to manage. We're going to spin up a couple teams and solve this problem by building out a Mesos platform and tooling on top of that to handle building, testing, and deploying. And that new stuff, it was pretty good, but for DR, you still have to do things like bring everything else along. And it got so bad to the point where, this is a PR from DR 2017, that we made a bunch of changes to support in our Puppet environment and then closed because we weren't comfortable merging it because it was so risky for us. And this is what DR was. It was just a lot of busy work and toil. Centurion, our Capistrano-like Docker deploy tool. This is Ruby. It's a rake file. So you can do anything, but we mostly didn't. It was a lot of hard-coded information. Okay, here are the environment variables this service needs. Here's the host it's deployed to. So for DR, I copy-paste it, and I tweak some things. For service discovery, we had a much better story for Cerveza. This is a Ruby snippet to talk to our feature flag service. And this didn't need to change at all. As I mentioned, I may not have mentioned actually, we stopped using this around 2015, stopped using it in new applications because there were things about it that we didn't like. And so instead, we had big blocks of code that hard-coded information about where to find services. So you had to change this every time you wanted to add a new environment or change something about the environment itself. And our newest system, our Mesos platform and the Grand Central tooling on top of that, it was a lot better. Building and testing was amazing, but the deploy side of things was less good. Certainly, having a marathon system under the hood meant that we didn't have to manage host information, but getting environment variables into the system was just copy, paste, and tweak. So DR, kind of the same. So we knew that the problem with DR was that every team had to make changes to their software. And this was going to be true for every new region that we built out. So we needed to figure out what changes we could make to allow us to spin up end regions. So let's talk about interfaces, both between different parts of the technical system and between teams in the infrastructure. So the important thing to remember about interfaces is that they separate the contract from the implementation. This is more or less the textbook definition. So let's look at a real process. This involved humans in both the interface and the implementation as an example of the kind of optimization we can do. So historically at New Relic, to get database credentials, you as a service-owning team would file a ticket with the database team. They would go and provision a user on the database with the permissions you requested. They would then securely share those credentials with you. You'd put those in Vault, and then you'd be able to deploy your service. And this is just a human-driven process. There's really no good way to optimize this as is. But if we say, tweak this a little bit, we're going to programmatically declare that the service needs access to the database, then some magic is going to happen, and then we're going to be able to deploy the service. Even if inside that black box, the database team is still actually getting a ticket and adding credentials to the database and sharing them and maybe putting them in the right spot, this is still something the database team can say, okay, we're going to actually just go ahead and automate this. This is really painful. And the key thing here is that they're able to do this on their own, because encapsulation lets small teams act independently. Before, a project to change how we do database credential management would have required every single team at the company to change. But now the database team can say, we have an idea about how to make this better, and just do it themselves. So what we needed to figure out were what were the high-leverage interfaces that we were going to implement as a part of this project. What were we going to do to unlock the nth region? So first, service discovery. So there were a mix of problems that we had, or mix of solutions that we had. We had our Cerveza system, as I mentioned. We had a lot of hard-coded information in code and YAML configuration files. We had environment variables for some services, and that information was typically provided in also via hard-coded configuration. We didn't have a great way to do credential management. We had a good way to do credential storage, but where those credentials came from, that was sort of an unsolved problem. And we also had no way to do static analysis of this system. So let's talk about why static analysis is a useful thing to have for a complex architecture. So if I'm deploying Service Alice, say I'm building out a new region, it would be really nice to know that it depends on Service Bob before I find out by Service Alice just being broken when I didn't deploy Service Bob. If I knew as a matter of fact that Service Bob was depended on by Service Alice, I could just deploy it first and deploy Service Alice. Just having this data at all unlocks doors. And if the only way that you can find this information out is by looking at runtime behavior or by trying to extract information from the code that's not designed to be statically analyzed, there's gaps in this information, and you're not going to be able to trust that you actually know what the system is doing. So what we decided to do instead is re-architect our service discovery system so that, as a matter of course, if Service Alice talks to Service Bob, it has to declare up front that it wants information about Service Bob in a way that a computer can understand. So we can say Service Alice is going to declare this, that in order to talk to Service Bob, there's no way that I can do this without actually declaring it. We had services that would use information like, OK, URLs for services, and we had a variety of different formats that they would use, but we could settle on one and standardize on a syntax. We had a syntax for accessing Vault secrets in our Grand Central build and deploy tool. So we could extract something similar for discovery, a discovery path that says, I don't really care what the value is, just tell me where Bob is. And we can repeat that same pattern for the other side of the problem, which is credential management. So the classic story is databases. If Service Alice depends on a database for it, it needs information about how to access that database. And we can extend the URL, pass that information in, and amend the discovery path syntax to allow declaring that it needs an authenticated URL string for that service. This is service discovery as dependency injections. Services declare their dependencies, locations are injected via environment variable in a standard format, credentials are part of those URLs, and static analysis is possible. And this is a pretty convenient system for understanding the architecture of a system as a whole, and it's also something that isn't blocking us in too much. At the end of the day, all we're doing here is specifying a format that services use to access their dependencies via an environment variable format. So if we learn that the format that or the system we're using to generate that information is wrong, we can change it. The next thing that we did is we said, OK, containers are great. In fact, they're so great that we want to put them everywhere. And we knew that containers provided a good interface between the development team and the machines that their services were actually running on because we'd been such early adopters of Docker. And at the time we made the decision to standardize on containers across the board, most of our services were already Dockerized, but they were difficult to operate via Centurion. So we said, great, we're going to simplify that whole class of problem. Everything's got to run in our container fabric, our Mesos platform. Our stateful systems, on the other hand, mostly weren't containerized. They were running on bare metal, typically on machines of their own. But we did have experience running a large Cassandra cluster in Docker for a couple of years at that point, so we knew, OK, this could be done. And actually, we'd built out a relational database platform for running many databases on a single machine that we'd been using in production for a few months at that time. So we were confident that we could make this work. We weren't confident that we could say, as part of this project, we're going to run all stateful services on Kubernetes or on Mesos doing that orchestration for us. That would have been really risky. But we're setting ourselves up for that option in the future. Next, standardizing on CoreOS, not CentOS. So we'd been running on CentOS at New Relic for basically the entire existence of the company. But it has some problems. And CoreOS is a much better solution for our problem these days. CoreOS is a Linux distribution designed to run containers well. That's its job. And it solves two related problems for us. First, the configuration is just much reduced compared to other Linux distributions. It doesn't even have a package manager. So it's to the point where if you want to do anything useful at all, you just want, as a user, to put it in a container. And that's exactly the behavior we want to encourage. And it has a nice first boot configuration system, Ignition, that's well matched to the configuration that CoreOS actually supports, which is convenient because that means we can abandon our unloved Puppet installation. Puppet can do a lot more than Ignition can, but if we don't need it to, then we can use something less powerful. And there's another advantage. CoreOS publishes a tool called Cloud Config Transpiler that allows us to translate relatively human-readable JSON into the much less readable, human-readable Ignition JSON format. And it's available as a Go library. So we were able to integrate it into our machine provisioning system and make assertions about what was actually being provisioned. So here I'm declaring that there is a YAML block asserting that there is going to be a New Relic infrastructure agent on every one of our machines. And finally, the last thing we did is we standardized on Terraform for this environment. We didn't necessarily want to retrofit this into everything that we had already, but for future work, a lot of infrastructure is just fiddly customization. The S3 bucket configuration for this service is different from that service. The load balancer configuration just slightly different for this one than that one, and there's not necessarily a great way that you can abstract that away. But just putting that in code is really valuable. And the Terraform project and community provide a lot of off-the-shelf providers that make different cloud APIs accessible from Terraform, but you can also develop your own. And we found that biting the bullet and developing Terraform providers to close gaps paid off repeatedly. For example, as I mentioned, we're running in IBM's cloud, which provides us bare metal machines. And the bare metal machine lifecycle that IBM provides is not exactly what we'd want to use, but we were able to write a Terraform provider that encoded the lifecycle we wanted to see and then use that from our software. So all that said, bundling all of this work together may sound really risky to some of you, nearing like a second system level of project. And you're probably right. This was just really risky. We did try to de-risk it some by choosing problems not to tackle. For example, not putting all of our stateful systems in Kubernetes on a timetable. And we replicated our F5 load balancing tier, which was run in hardware in our US region, by running virtual F5s in CentOS containers on CoreOS as a way of just saying, cool, we're going to isolate the mess and keep our F5 load balancing tier around until we have a time to work on that in the future, not bundling that together as part of this project. But all of that said, if we hadn't done this work, we might have ended up with twice the operational load by having a new region, and worse, the same time to build a new region. And if we repeated this a few more times, if the business had said, great, it's time to build out an APAC region, time to build out another, we might have just dragged the company down under endless operational toil or be forced to turn down business opportunities by not building regions at all. So to summarize, we chose to implement a few very high leverage changes. There were, of course, more that we could have done as part of the project, but we tried to walk the Goldilocks balance between too few changes to achieve our goal and too many changes to get done. So all of that said, we had an execution plan. What we hoped would happen is we would do some discovery of the IBM environment and of the changes we needed to make, and then document changes that we needed teams to make, and then broadcast that it was time for all teams to do this work. Then teams would do the work in parallel. We'd do some repeated test build-outs, find out what wasn't working, repeat, and then finally stand up a for-real environment and leave it running. Then we'd test it, and then we'd ship it to our customers. And the hope here was that by doing all this work in parallel, providing the information up front, that teams could schedule other work in between the work that they had to do. For example, we had other high-priority projects like our distributed tracing support that we shipped earlier this month. And there's no way that we could have done that if we had kept teams busy for the entire 9 months or so between now and when we started this project. And all of that's great, but I wouldn't be up here talking in front of you if the project had gone perfectly. Or maybe I would be, but I think that would be pretty boring, because honestly, none of the things we did technically are all that unusual. Maybe the combination is somewhat unusual, but to me what's more interesting is the fact that we did this at some scale, both technically and organizationally. So I'm going to go over some lessons we learned along the way, and sum each one up with a set of things that we'd start, stop, and continue in future large-scale projects. And I hope that these are all lessons that can be relevant to you as you consider large-scale projects of your own. So first, quick ramp-ups. How do you prioritize your work? The Backpack project was predicated on getting support from the business so that teams put this on their roadmap to make changes to their software. So let's talk about how road mapping works. For us, each engineering team at New Relic is autonomous. They have their own roadmaps set by the team and by their product manager to meet both the team's own goals, reliability, just general code cleanliness, features that they want to implement that they would think cool, and the broader requirements of the business. And the broader requirements of the business come from every quarter or so. The product council, it's a group of leaders, publishes a list of up to 5 high-priority projects that are going on across the company in order of priority. Not every team can contribute to every project. For example, the top-line project may be a project that only one team can work on. And what that means is that every other team just needs to make sure that that team isn't blocked. So if something is blocking that team, they should probably stop what they're doing and figure out how to help. Other projects on the list indicate that there's work for all teams to do, and so that they need to schedule that into their roadmap. And this project actually works. It's been pretty successful for us since we implemented it a couple of years ago. But there's a catch. What happens if there's a project that's going on and it doesn't get prioritized in time? That's what happened with this project. There was a month or so of delay past where the project should have been prioritized but wasn't, and then all of a sudden we were prioritized. So I grew up in Los Angeles, and I remember going to California Adventure and getting on this roller coaster. And I was really surprised when it turns out it was a fast start. It went from about 0 to 60 miles an hour in a few seconds from nowhere. And I smacked my head. And that's what happened to me here and the other people I was working with. We just weren't ready. In retrospect, this sudden swing of support from no support to near total support just wasn't good for the project. We suddenly had to transition from operating relatively independently to having every team in the company trying to figure out what they needed to do to support the project. That discovery work was well organized, but even still, it left the Backpack engineering team scrambling with our sudden success and getting attention. We weren't ready with documentation, service discovery, or other core tooling. And worst of all, we didn't have an easily digestible philosophy to help people make decisions. We couldn't predict everything up front that people were going to run into, and we didn't provide them the information they needed to make those decisions well. There was thrash throughout the project, thanks to us not clearly communicating what some of the secondary goals of the project were. If engineers had internalized those, there likely would have been less of that thrash. So in the future, we're going to start preparing for what happens when a project suddenly receives high priority. We're going to produce a project philosophy document, but we're going to continue prioritizing important work across the company. And related to that, the biggest problem that we ran into was that the project was rightly seen as continually moving goalposts for teams. So we specified up front there's going to be some work. There's going to be containerization, moving to container fabric, and service discovery via environment variables. But we, the project leads, also knew that there would be iterative, smaller work to come as some platform features became available. For example, our initial instructions didn't really mention the fact that we were building out a service discovery system that would be using the discovery path syntax, because that wasn't ready. We said, teams, please get your services ready to use values in the format that this tool is going to provide. But we didn't mention that that tool would be coming along and when it would be ready. When it became ready, we called it out, and suddenly there was more work to do. It wasn't a lot of work to do compared to changing the service to actually accept the value in the first place, but it was still work. And this was intentional for 2 reasons. First, at New Relic, each team has a hero role that passes around, typically via an on-call rotation. And they're supposed to handle questions, small requests from other teams, people across the company. So we thought that those heroes could handle the smaller stuff that we had coming in. Like, okay, cool, we need you to make this small change across your 5 or 10 services. It's going to take you a few minutes per service. Please just go ahead and do that. And we also didn't want to exhaustively list work that teams couldn't do yet, because the worst thing that could have happened was that teams would have said, okay, you're not telling me that you're ready for me, so I'm not ready for you, and I'm going to wait 2 months while you get everything together before I start. And if everything had gone perfectly, that would have been fine, but we expected problems, and so we wanted teams to get a jump start. In retrospect, this was a mistake. Most importantly, in not communicating there would be follow-up work at all, even if we didn't know the full extent of it. Also, the fact that the team's hero rotated so often meant that the team's hero wasn't necessarily the person who'd done the EU supporting work in the first place, so they had to context switch and get up to speed. And that's one kind of moving goalpost. There was another. We ran 3 build-outs as part of this project, one in December, one in January, and one in February. And our goal when planning this was to allow us to iteratively iterate and improve the infrastructure side of the build-out. Like, for example, figuring out that our initial networking configuration wasn't going to fly, and have a time when we could say, cool, we're going to reprovision all of the machines, and no one's going to get mad at us. But what the build-outs actually were just repeated integration exercises, finding out exactly what wasn't working correctly yet. So the reality of the build-out was that we'd encourage teams to do their EU supporting infrastructure work in the US, deploy it there, test it out, et cetera, but there were still issues that could only be done in the new environment. So what they'd do is they'd do the work, hopefully test it in the US, they'd wait a few days or weeks, and probably move on to something else. The backpack team at that point would try to deploy the team's software, which we had implemented as a means to try to make sure that people weren't making unwanted shortcuts. And then the backpack team would find a problem. They'd go to the team's hero, say, hey, your service isn't working, and now the team would feel under pressure to fix it. And sometimes this pattern actually happened a few times, which wasn't pleasant for anyone. And even though the goalposts weren't technically moving here to us, at least, the goal was always, it works in the EU. That's a pretty ambiguous goal. And the reality is the team thought that they were done, and then they weren't. So we just didn't consider how bad the context switching of rework and thrash would be. In the future, probably what we'll do is try to implement more of a steel thread approach. This is a term that we use at New Relic that is somewhat industry standard. It's the idea of validating a design using a small subproject and testing out all the implications thoroughly before involving everyone else. This could have had a downside in the sense that we may not have gotten the right teams involved, or it may have extended the overall wall clock time of the project, but it probably would have gone better than it did. So in the future, we're going to use a small number of teams that form a complete system as a test case. We're going to try to be more honest and transparent. We're going to stop having hidden work, even if only by acknowledging that some unknown future work exists. But we're going to continue to avoid waterfall planning. There's no way that we can predict everything up front for a project of this size, and we need to be able to still be as agile as we are on smaller projects. Next, communication is hard. I know this is a real surprise. So New Relic has a strong culture of internal blogging as a means of broadcasting ideas and posting updates on projects. Every step of the way, the backpack team wrote posts about the ideas behind the project, the changes we needed made in team software, plans for build-outs, and just what the team did that week. Here's an example of all the posts from like a 1 or 2 week stretch. And the trouble with this with an internal blogging culture is that it's not like there's one team doing this, one person doing this. Everyone's doing this. And that means that you as an individual just can't keep up with it all. You don't know what you're supposed to be reading. You don't know what you're supposed to be keeping informed on to keep up with your job. And so, we tried other things. We're like, okay, we're going to have some town hall events, invite the entire product organization, talk about what we're doing. But those have problems too. Blog posts, they don't get read. Town hall events, they're optional. People are on vacation. It's at 9 a.m. because we have an office in Barcelona and people don't want to get in that early. Just random problems like that. We tried to deploy a checklist application to help with this problem, where engineers could say, cool, this step of the project is done for this service, but if you add something there, an engineer has to notice if they didn't read the blog post saying that something was added there, and they have to know to go there in the first place. We tried to use our linting infrastructure to say, hey, this line of code is going to be a problem in the new region, but our linting infrastructure is out of band and it's not widely used. So teams that used it found it helpful, but others did not. And emails, they also don't get read. The solution that we found that did help, and we've unfortunately found this a few months too late, was just centralized documentation for what needed to happen. We had thought that producing documentation in the form of blog posts along the steps of the project would be more useful than a large document repository, but we were wrong. What we could have done instead is have a document repository with the changes that needed to be made, and then point to those from blog posts saying, cool, we've changed this, we've added this page, go take a look. And that way, somebody coming into the project a month late wouldn't have been struggling to find out everything that they needed to know. So in the future, we're going to start putting all project requirements and deliverables in one place with a user-readable changelog, because things change. And note, a git commit history is just not good enough. That's not human-readable. We're going to have better linting. We're going to continue, though, to blog internally. It's really useful for us. And we're also going to continue to communicate using as many channels as possible, because one is not enough. Next, local maximums. So one consequence of our incomplete standardization in the past and now is that teams are heavily incentivized to make their systems better now than at the time that they're actually dealing with problems. So let's do a thought exercise here. Go 3 years back in the history of New Relic, and you're on a team and you own 20 services, let's say. They're all part of a whole system, you understand them, but there are some things in the standard platform that you just want and New Relic doesn't provide to its engineers. There are no chain deploys, for example, between staging and production, or between service A and service B. For example, if you have this all in one repo, you might want to push all of these out at once, and you don't want to be going click, 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 let's deploy all of these. There's no shared configuration support, and there's no service discovery. So cool, you build all of those things. And you get 3 years of benefit out of that. That was absolutely the right decision for your team and you at the time. Fast forward 3 years, and you've had that, but you don't have the standardized platform that was built in the meantime. And now someone's asking you to use standardized tooling. This is going to be painful. There's going to be some kind of transition pain, but the promise is that the standardized tooling is better than what you've built. In reality, there are some aspects where that's just not true. There's this future promise. The tooling is going to be better than what you have, and it probably is better than what you have in 90% of the ways. But if your team had a specific problem that the tooling didn't consider, or, for example, the tooling team thinks is an anti-pattern, it's a possibility, you might have a rough time of it. You might be unhappy. And this isn't a good way to make friends if the project to build out an EU region is saying, cool, we want you to be on Container Fabric, and the only way for you to be on Container Fabric is for you to use Grand Central, which is the standardized tooling that you haven't used. So there may not ever be a benefit that the team sees from this work. The real benefit is to the organization as a whole, because the next project like this can come along and change the standardized tooling, and the team doesn't have to do work. They don't see that that work never appeared on the roadmap in the first place. It's just a problem now. So I don't have a good solution for this problem, but I have some ideas. First, just having more empathy for teams stuck in a local maximum is really important. Communicating well in advance can also help, because if they can realize that the tools don't match their expectations in certain ways, they can communicate with the tooling teams and hopefully get a little work done to close those gaps. But I think the most important thing we could have done differently is to try to stop making assumptions about how teams and individuals will react. We may think that, that team over there, they've built a lot of their own tooling, they're going to be really upset about moving to standardized tooling, when in reality, they might be sick of maintaining that tooling and happy to adopt something that somebody else maintains. Or we might assume that a team that doesn't have standardized tooling will be happy to adopt standardized tooling, but for whatever reason, the people involved, the technologies they're dealing with, the other work they have on the roadmap, they might not be happy. So just stopping making those assumptions at all was probably the most important thing we could have done. But we are going to continue making standard tooling better, most importantly, to make projects like this easier. Probably the best decision we made was leaning on what we had, most in the form of piggybacking on work that was already in progress. We had a few in-flight projects that were key. We couldn't have done this project without them. We had our Container Fabric team building out our Mesos platform, build and deploy tools building out the build and deploy system, and our database engineering team building Megabase, a containerized database platform. This was great. But similar to the experience of the Backpack team when the product council prioritized the Backpack project, the teams running migrations already in progress saw huge upticks in adoption thanks to Backpack. That's great because people were using their stuff, but it can be really stressful when you're at a pretty steady migration rate, and then suddenly the slope of that line changes dramatically. On the other hand, one of our design goals here was to put the work of infrastructure improvements on a small number of teams, not to spread it across every team at the company. So in that sense, this was the right decision. In the future, we're going to start making clear which priorities are highest for infrastructure teams. One other thing that happened is that we had a little bit of trouble at the beginning of that work making clear which features were most important to enable the multi-region project. But we are going to continue to leverage high-leverage work that a small number of teams can do. Last lesson learned, the importance of a pilot phase. So our original plan, as I talked about earlier, was we were going to do discovery, fan out and do the work, test everything ourselves, and then ship it to any customer that wanted to keep their data in the EU. And we realized earlier this year that we have SLAs with our customers. We have obligations to them that say, if we don't meet the standard of reliability, we're in trouble. And we weren't confident enough that we could just ship out of the gate and meet those standards for reliability, which would have been not good for us and for our customers. So we changed the plan to add a small number of friendly customers to a pilot, where we could build out a region, have customers actually using it, and not be on the hook for reliability in the same way when things inevitably went wrong. And this was absolutely the right decision. Just having wall clock time with real customers that expect and accept problems allowed us to experience both bugs on our side as well as incidents in the underlying cloud. We can never completely avoid problems, but at least we can practice our response in a new environment. So here, I think the most important thing is just to stop magical thinking. I honestly have no idea how we ever thought it was okay that we were going to do all this work on a multi-month, almost year-long project and then just ship it and everything was going to be fine. All right, that said, where are we now? The most important thing to note is that this project as a whole did work. We have a European region in the pilot phase right now, and if you're interested in this, stay tuned in the coming months. You'll be hearing more. In our disaster recovery effort earlier this year, we saw a lot of benefits from this project. The number of engineering hours involved decreased by an order of magnitude. And that's going to only continue to improve as we continue to close gaps in provisioning regions. We're not at the goal of one small team yet, but we're well on our way to it. We have less busy work in just normal operations, and we've laid the groundwork for further iterative improvements, most notably because we have 95% of our services in Container Fabric. And there's a meta benefit too. We're an observability company, and the more that we expand our operations to stay on the bleeding edge of software and infrastructure practices, the better able we are to serve customers doing the same. And as heavy users of New Relic ourselves, we're continually running into the rough edges of our own product, and we're making it better. And finally, we've just learned a lot about running large-scale projects, and that's going to continue to help us as we grow. Delivering features as a small team is fun and it's valuable, but when you can successfully coordinate large numbers of teams, you can do amazing things. So in the future, we're going to continue trying a little bit of magical thinking, thinking that we can do big things. Thank you for listening, and more importantly, thank you to the hundreds who contributed to this project.